Okay, here we go. This is a video for section 1.7 of the Math1 textbook on multiple step inequalities. Okay, so we are going to start with a review of the symbols that make up inequalities. The word inequalities means not equal. In as a prefix means not equal. So our first symbol is this symbol. Do you know what that symbol is? If you said it's the less than symbol, you are correct. On the other end of that, there's this one, which is the greater than symbol. If you have trouble mixing this up, my way of remembering which one is which is the less than kind of looks like an L. Awesome. Then there's also this symbol, which this little line underneath means or equal to. So this would be less than or equal to, which means not only should the number be smaller, but it could also be equal to. And similarly, we have the same thing for greater than or equal to. Okay. Let's look at the differences between solving inequalities and solving equations. In your notes, you don't have to copy this whole thing down. Just get the important ones, and I'll kind of highlight the important ones here. First of all, the similarities to solving equations is we're going to follow the same steps. These major steps that we already know how to do. We're going to distribute first if we see it. We're going to simplify like terms. We're going to get variables onto the same side. We're going to identify what's happening, and then we're going to undo what's happening. Same old deal. The idea here is still to get the x or whatever variable you have alone. But instead of x equals, you're going to have like x is less than or x is greater than. It's still telling us something about x. But that answer is not considered one number anymore. If we have x is greater than 4, the number of answers that you can think of for x that are bigger than 4 are an infinite number of answers. 5, 6, 7, 21.3, 4.01 is greater than 4. Okay, one answer that wouldn't be a part of this is 4. 4 is not greater than itself. That's not true here because we don't have the or equal to. If we had the or equal to, then 4 would be greater than or equal to 4. That would count. Alright, two major differences. These I do want you to make sure that you've got down right here. Or 3, I guess. The top 2 are most important. When you multiply or divide each side by a negative, the inequality sign switches. That is huge. I'll go over on the next slide why that's true. And also, if you switch sides, the inequality sign changes. And that didn't happen in inequality. If you have x equals 2, you could say 2 is equal to x. This is the same thing. This is saying if you have x is greater than 2 and you want to change it, it better be 2 is less than x. Again, I'll go over that in more detail. So let's talk about why does multiplying and dividing a negative change the inequality sign? Well, let's start with some numbers. 5 is greater than 3. True? Yes, 5 is bigger than 3. If I were to multiply both sides of this inequality by a number, let's say 2, I get 10 is greater than 6. Is this still true? Yeah, 10 is still a bigger number than 6. But what if I made this into a negative 2? Well, then I'd have a negative 10 and a negative 6. Negative numbers, the bigger they are, it's actually the smaller they are. So negative 10 is actually smaller than negative 6. So this is no longer true. So that's the way they work. So why does switching sides switch the inequality sign? Well, this one's a little easier to understand. If I say 5 is greater than 2, and I want to put the 2 over here and the 5 over here, what symbol should go here? Does it stay a greater than? Is 2 greater than 5? No, we know that. It's not true. It would have to switch, and it would become a less than. All right, let's do graphing of inequalities. One other, up here, the third major difference is we have to graph our answers on a number line. Because there are so many, we want to identify them all. So let's do, for example, x is greater than 4, like we were talking about. Well, we want all the numbers that are greater than 4. So that includes 5, 6, 7, 8, but you have to also think of the decimal numbers. 6.5, 6.2, all of these numbers in here. There's all of these numbers that you have to consider. And even all the way up until 4, but I can't say 4 because, as we said, 4 is not greater than itself. So what we do to represent that it's going all the way up into 4 but not including 4 is we put a nice big open circle. Okay, so for the greater than or the less than, those are open. Now, to say that it's going to keep going, it's not going to stop at 8. That's just what this number line stops at. We need to put a number or a arrow at the end of our line here to say it's going on forever. It's going to infinity. Okay, because we can't count how high it goes. All right, let's do another one. Let's do a less than. This time I'm going to do a less than or equal to -2. Okay, so numbers that are smaller than -2 are to the left of -2. So -3, -4, -5, etc. And also all of the numbers in between. Now this time, because I put that little bar underneath it means equal to, -2 counts. So instead of putting an open dot, we put a closed or solid dot. And then we're going to also keep going on forever in this direction. So with less than, we're getting smaller, which means for negatives, it kind of means like you get bigger negatives. Okay, let's do another one. Let's say you have to graph 3 is greater than x. Well, notice where the x is. It's on the right. When we graph it, it's easier to think of the x on the left and the 3 on the right. So the way that we want to do this is we're going to switch this inequality sign. So it's a less than, remember? So if 3 is bigger than x, x is smaller than 3. Now this is easier for us to graph. So at the 3, I know it's not going to be a closed dot because it's one of these. If it was one of these, it would be closed, or solid sometimes we call it. So x is greater than 3 is not going to be closed because we don't have the equal to. So we're just going to put an open dot here. And it's less than 3, so I'm going to go smaller than 3. So I'm going to go in the direction 2, 1, 0, all the negatives. And I'm going to put an arrow at the end, and I'm done. Okay, let's talk about solving. Like I said, the steps to solving are pretty much the same. I look for distribution. I don't see any. I look to combine like terms. I don't see any. I'm looking at what is happening to the variable. I see what is happening first is it's being multiplied by 7, and second is we're subtracting 5. So when we undo that, first thing I'm going to do is the opposite of subtracting 5, which is adding 5. Then second, I'm going to undo multiplying by 7, which is dividing by 7. So I'm going to add 5 to both sides. That goes away. 7x is greater than or equal to -21. Don't change this at any time to an equals because it's not. Alright, next we divide both sides by 7. Now because I'm dividing by a positive number, I don't have to worry about switching signs. And so I get x is greater than or equal to -3. Now I'm not done, I have to graph it. So my first thought is, where's -3? Okay, it's right here. It's greater than or equal to. That or equal to means solid. So I have to make a solid dot at negative 3. Negative 3 is part of the answer. Then I think about what's greater than negative 3. Negative 2 is, negative 1, 0, all the positives, and on. Okay. Next example. Okay, I check for distribution. Don't have it. Combining like terms. I don't have it. Let's undo what's happening. So first what's happening is we're multiplying times a negative 2. Then second, we are adding 4. Undo it. First thing I'm going to undo is, I'm going to undo adding 4 by subtracting 4. Then second, I'm going to undo multiplying by negative 2 by dividing by negative 2. So subtract 4, negative 2x is less than 14. Divide by negative 2, divide by negative 2. Okay, now I am dividing by a negative number. That is where we have to change the inequality sign. So this is a less than, I'm going to finish my problem down here. My negative 2 cancels and I get x is greater than. It changed. It was a less than, now it's a greater than. That's the key. I don't like that circle. There we go. And then over here I have negative 7. Okay, so I have x is greater than negative 7. Here's negative 7. What kind of dot should I put? Open, because it's not there's no underline here. That means it's not equal to negative 7. Okay, so greater than negative 7, we get this way. If your x is on the left, you can think of this sign as an arrow pointing to the direction, because greater than is always going to the right and less than is always going to the left, just like the less than sign. Okay, one more example, a little bit more complicated. Alright, we have distribution to do here, so I'm going to distribute the negative 2. I get a negative 6x minus 10. Don't forget you are distributing a negative 2. Okay, then greater than or equal to 2x. Next I want to see if I can combine any like terms. I can. I have a 5x and a negative 6x. 5 minus 6 is negative 1x. Minus 10 is greater than 2x. Okay, now be careful here. Don't start undoing what is happening to the variable. We have variables on both sides. That's our third step. We don't often do it, but we need to do it here. So I need to get those variables onto the same side. Now you have two options, but only one of them is really going to be a good idea here. You can move either the negative 1x over there or the 2x over there. But if I move the 2x to the right, or I mean to the left, I'm not going to have anything left over here. In those cases, you don't want to do that one. So I'm going to move the negative 1x. So to move it, I need to add 1x. Okay, let's see what we get. Let me move up here. Negative 1x plus 1x goes away. I get negative 10 is greater than or equal to 3x. Then I have to divide by 3, because that's the only thing that's happening to the x, right? It's multiplying, so I'm going to divide by 3. Okay, so negative 10/3 is our answer. 3 doesn't go in there. Now, first thing I notice is the x is on the right. I don't like to have the x on the right. I'm going to put it on the left. And I can put the negative 10/3 on the right, which is fine. Just remember you have to change the sign. Now the other thing is I don't know how to find negative 10/3 on the line. So this is one of the few cases I actually prefer mixed numbers. So let's see, how many times does 3 go into 10? Well, 3 times 3 is 9, so that's 3. Our answer is negative. And then that would be 1 left over remainder, because I'll just show you what I'm doing so you can see it. I'm just dividing 3 into 10. 3 times 3 is 9, subtract 1, and so it's 3 and 1/3, but negative. So in this case, we're going to estimate. Negative 3 is right here. Negative 3 1/3 is right here. So that's where our number is going to go. Now, we want it to be a solid dot, so I'm going to put a nice big solid dot at negative 3 1/3. And it's just estimation. And we need it to be less than or equal to. So I'm going to erase this little dot that I had right here, because that's not part of our answer, because we're going this way. We're going less than. Okay, that's it.